Thank you very much. I hope you can hear me. I'm Jacek Oskarbski. Yes, we can hear you.
Szanowni Państwo,
So, ladies and gentlemen, in the first presentation of this session, I'd like to say a few words about using simulation methods and how we can use them to get substitute measures for road safety research on sections of expressways and motorways. Yesterday, this publication was made in the Sensors publication, and can I just encourage you to read that, to learn more about the details of the study. I am now trying to change my slides, but it doesn't seem to be working. Right. Thank you. I think it's working now. So the methodology for ITS, well, this really goes back to the theory of traffic conflicts. Towards the end of the previous session, there was a presentation by Dr. Giedź. And this presentation really ties in to that presentation, which we've already seen. One of the services provided by Intelligent Transport Services is speed control, with the information being provided to drivers using variable message signs. To study this, we used the simulation models. So they are traffic models, and we also used a driving simulator. When it comes to traffic models, we use models of a varying degree of detail and the possibility of representing the reality. We used macroscopic, meso, and microscopic. Well, with macroscopic models, we acquired data following the surrogate safety assessment model. In that model, we compare vehicle trajectory if specific threshold values or boundary values are accessed. For example, vehicle trajectory is too similar, which means that there may be a traffic conflict. When we did our studies, we compared the vehicle trajectories from simulation studies. So in our study, we used a test traffic model, which we developed for the corridors of Polish motorways and expressways. The test models were developed looking at road class and the actual road network. We would input different traffic volumes to simulate different traffic movement freedoms. So we parameterized the data using data from traffic count stations, which means that we had access to real data. During the simulation studies, we simulated situations such as incidents on the main road, and that meant difficulties. For example, reducing capacity, and that depended on whether we needed to close off entire roadways or lanes. When there's an incident and the duration of the incident, so this was based on data we retrieved from regional fire services. We also estimated the number or the share of vehicles which used alternative routes when there was an incident. So we used the Viator traffic system. So the data were used to calibrate and validate simulation models. During calibration, we used data from traffic control stations. And so we developed empirical time intervals for the cars for different traffic volumes. These distributions were then used to calibrate the follow the leader model. And we also identified the speed distributions for different road classes to calibrate driver behavior in the macroscopic model, if provided with variable message signs, we used driving simulator results. The study was conducted by the Motor Transport Institute, Warsaw. The results from the driving simulator helped us to identify the areas where drivers would slow before a variable message sign, which displayed a speed limit, and then they would then accelerate once past that sign. We were able to identify the dynamics of speed change and the scale of the change. The driving simulator was also used to understand the reaction of drivers to variable message signs when it comes to staying in lane, meaning changing the distance between the axis of the traffic lane and the longitudinal lane. So the content of variable message signs didn't really contribute much to standard deviation and lateral deviation when it comes to vehicle position, but what we were able to see was an interesting relation. And it's something that everyone has a sense of intuitively. So there is a positive effect when the speed limit sign was accompanied as to why the speed limit was introduced. And now moving on to presenting the results of our study, I'll talk you through the scenarios first, because we compared different scenarios using traffic simulation models, looking at traffic corridors. In our studies, we looked at different scenarios of speed control. The baseline scenario, which is the zero option, no messages. We then compared this against one VMS or a series of VMS between interchanges. We also analyzed scenarios where an accident was simulated in between the interchanges. For an expressway under saturated conditions, well, we can see this here on the right-hand side. So there is an improvement in terms of road safety, especially in the speed limit information if it's provided by a series of VMS. And then delays are shorter and there are fewer stoppages. When it comes to safety based on the number of conflicts, we can see a significant improvement on the main road, but also at interchanges. The severity of conflicts, which we calculated like this, where it was the number of conflicts involving vehicles where the speed variance was more than 20 kilometers per hour. And we were able to reduce that significantly by using VMS. We could see positive results when it comes to rear-end collisions and changing lanes. Well, I think this suggests that dynamic speed control systems have a positive effect by ensuring consistent speeds. And that claim is confirmed by conflict density observations, looking at the different scenarios, and also the location of the conflicts is important here. When we use dynamic speed control using a series of signs, that's scenario 2, W2, there are fewer conflicts, but there are also fewer conflict accumulation sites, which is the distortion wave, which could happen under saturated conditions. When we compared scenarios involving a 30-minute accident on a major road, and you can see it on that chart. If there's an accident in the scenario, well, we can see the positive effect of using a series of variable message signs. So they have a positive effect on road safety, and that effect increases as volumes grow. Well, using dynamic speed control does not really affect the speed of restoring normal conditions or clearing the road lane after the incident. We analyzed another scenario, which you cannot see on the chart, but what we assumed there was that we would have speed control, but also staged access onto the main road. So using these two things, which is gradual traffic and the speed signs, the effects were much better, and we were able to restore normal conditions quicker. Moving on to the conclusions. So just a few comments. So I presented some replacement measures that can replace traditional statistical studies, especially in the case of innovative implementations when field or statistical studies are difficult because data are scarce or there are too few data or they are not available. And so that methodology can support the development on guidelines on VSL system structure. So some data are available from the General Directorate for National Roads and Motorways, and they use it to develop the national system for traffic management. But I think that the document, the instruction needs expanding, and I think, in fact, it should be written all over again. And it's not just about speed control. These comments equally apply to other services. So the elements to be included is the location of the devices, for example, the location of VMS, the location of traffic count stations or generally detection stations, or the strategy of traffic control. So the methodology I've presented could be helpful with developing guidelines for the services and ITS. The approach I've presented helped to determine the areas where drivers take decisions to change speed when they see the information on the VMS. So this can be determined using calibration of the microscopic model and also using driving simulator studies. In the future, we want to do more, and we will measure vehicle trajectories, speed change dynamics in the vicinity of VMS. We will be using radars, image processing techniques to validate the presented models. The methodology can be used for ITS services to determine the effectiveness of solutions, to ensure that they are optimally located, but it's equally important to provide information to drivers. The conflicts and the density of conflicts and the studies we've done in that area seems to be promising when it comes to ensuring homogeneous speed homogeneity. The results also confirm that VSL has a positive impact on traffic safety. There are fewer conflicts, they are less severe. So this shows that especially using a series of VMSs is really beneficial. And so the continuity of information is what matters. And so this could equally work for combined vehicles and autonomous vehicles. There will be more presentations about this further in the session. Thank you.